Hello, in this video we're going to look at basic exponential graphs. So what does an exponential function or equation look like? Well, it looks something like this. Y equals, I'm going to need some base. I'm going to use the base 2 and I'm going to put my x up here in the exponent. That's why it's called an exponential equation, because the value of x is in the exponent. So that's one type of exponential graph we'll look at. Another important type that we're going to look at a later stage is also this one. Y is equal to e to the power x. Now this might seem a bit strange. E is in fact a special mathematical number. It's called Euler's constant. And we just need to think of it as a number. In fact, you'll find it on your calculator. If we go and take a look at this button over here, in the yellow script, you can see e to the x. So I'm going to go shift e. I'm going to raise the power 1. And there is the value of e. It's this number 2.7188, no, not 8882, and so on. It's one of these special numbers, an irrational number like pi. And we use it a lot because it occurs a lot in growth patterns. The importance of the exponential graphs is that they are linked very closely to growth patterns, and that's why we like to study them. Now, enough of that. Let's go back and look at a table of values for our basic graph that we're going to look at, and that is this blue one over here. Y is equal to 2 to the power x. So I'm going to enter in y is equal to 2, and I'm going to raise it to the power x, and there I have my values, my equation. F6 will give me the table of values. And I've got values that are going from -4 through to +4. You'll notice as the numbers become positive, so I'm getting nice whole answers. But when the value of x was negative, I was getting these strange decimals, decimal numbers that in fact we could write as fractions, and we're going to talk about that a little bit later. So let's have a look and see what this looks like in terms of our graphing package. No, I don't want it as full as that. We'll move this across over here and get the graphing package in. There we are. And now we just need to go and get our different points. So when x was -4, we've got that a was equal to, or that the y value was 0.625. There's a very small number over there. When x was -3, we're going to get 0.125, which for those of you might recognize, that's the fraction 1/8. 0.065 is 1/16, as I said. The next one we look at is when x is -2. We're going to get that y is equal to 1/4. When x is -1, y is equal to 1/2. When x is 0, y is equal to 1. When x is 2, y is equal to 2. So when x is 1, y is equal to 2. When x is 2, y is equal to 4. When x is 3, y is equal to 8. We can't see that on the graph. Let's just scroll out a little bit. And just shift this down. Okay, there it is. And the last one, when go all the way down, when x is 4, y is going to equal 16, and I'm going to have to zoom out even further, and there it is over there. So we can see our graph once again has got a bit of a curve on it, and something strange is happening down over here. Is this curve going to cross the x-axis? What about this line up over here? Is it going to become vertical at some stage, because it looks like it's getting steeper and steeper and steeper? The graph, well, the graph actually looks like this. There's the graph of the exponential function. I'm just going to zoom out a little bit so we've got a bit of a clearer view of those values. And that's the typical shape of an exponential graph. So I've just made a copy of that. I'm just going to get this out of the way. Let's get this chap back over here and go and paste in the graph that we'd had there. And there it is. Here is our exponential graph. And this is the graph of y equals 2 to the power x. So we see as x is a positive number, we get nice big whole numbers. What's happening over here when x is a negative number? Well, when x is a negative number, we might have something, we might have something like this: y equals 2 to the power of minus 1. Now, if you remember the work that we did on exponents in the algebra course, that could be rewritten as 1 over 2 to the power 1, or in other words, 1 over 2, which is a half. If I have y is equal to 2 to the minus 2, this is going to be 1 over 2 squared, or 1 over 4, quarter. Y is equal to 2 to the minus 4. That's going to be 1 over 2 to the 4, or 1 over 16. So as x becomes very small, and a very small minus number, so the bottom number of our fraction over here gets bigger. The result of that means as x gets very small, the value of y gets very small as well. But it's never going to equal 0. So once again, we've got one of those asymptotes. The x-axis at this stage is an asymptote to this particular graph. The other important thing that we have here with this particular value is this point over here. And this is a key thing about all exponential graphs, and that is they will all pass through the point at 1 on the y-axis, no matter what the base. If I've got y is equal to 3 to the power x, and x is equal to 0, I'm going to have y is equal to 3 to the 0, and 3 to the 0 is 1. If I've got y is equal to 12 to the x, add x is equal to 0, y is going to be 12 to the 0, which equals 1. So no matter what the base that we work with, all exponential graphs are going to pass through 1 on the y-axis. Okay. So there we have some basics about exponential graphs. Hope this helps. Goodbye.